So in previous lecture, by using sample a toy example, we have discussed some time complexity, space complexity, and why Naïve base is better in efficiency of space complexity or trying time. We have see all those things. So using some a toy example. Now in this lecture, we have seen that by if you use some pair text data, how it is efficient and how it is a baseline model for a text classifications problem. Okay, so let's see step by step. So if you just think a classification technique, that is we have already in this age we have already used the Gmail, and they have one section that is spam mail. Okay, so to classify this kind of spam mail, so Naïve base is the most useful technique. So to classify the spam email, so So spam filter simple for Gmail or simple any email to using the spam email. So this is the most useful technique. Most useful baseline model means name based algorithm is the mainly used for the spam classifier, or a simple if you just to classify the text review a review. Just if you see any e-commerce website, they are in a product section, you have already see the positive review and some comments are in negative review. So how to classify this kind of thing? So just a kind of review classifier, it is positive or it is negative. Okay, just see that review. If you just go to the Amazon section for each product, in the below of the each product you can easily find the product review. Okay, how to classify which review is positive for this product and which one is negative? So to classify this kind of thing here, Naïve base is the most useful one. Okay, so it's too simple to write. If we write it for text classification, for text classification, this Naïve base is a simple used method. Is a simple used method. Okay, now let's see one by one. Let's see. So for a text data, and we will see this thing, how to use the text data for classifications purpose, for regression purpose, how to think. Just at the end of this series, or at the end of this, just we are now going to the supervised model. So after ending the all kind of supervised model, then we are simple using some techniques, some programming algorithm. We are just going to the life by using simple programming tools, some programming techniques. We are using some raw text data, and we are going to classify using simple this kind of algorithms. We have used this thing at the end of the supervised learning. Okay, suppose let's take we have a text data, and how we will processed in a real scenario. There are various kind of raw text data. There may be a link include here, there may be some stop words include here, there may be some stemmings kind of word include here. So there are various kind of raw things are included here. So we have not required this kind of thing. So first we have to eliminate this thing, because to classification purpose this is not required. So unless if we use our dimensions of the text, will unnecessarily increased. So we have to first remove this one. So for we have to remove the stop words. We have learned, we will learn this thing in the next series of lectures. We will learn this kind of things. We have to remove stemming words. We have to remove we have using n-gram things. What is n-gram, what is stop word, what is stemming, we have seen. And this is the simple pre-processing technique. We'll see this thing. This is a simple pre-processing technique. So after using simple this pre-processing techniques, we are if a suppose if a or let's take there have some kind of words, that is w1 w2 words. This is the words simply. Suppose let's take in a text they have these words. Suppose let's take you have d words. Okay. So how we will use this word to a vector? So simple, we have some techniques, such kind of, let's take we have some binary backwards technique, some there are many kinds of technique. Suppose like binary backwards means that backwards means if this word is present in this text, then we can use 1. If it is not present, then it will can use 0. Simple, this technique is called the binary backward. Okay, binary backward. And simple, this is means present or not. If it is present, then we are using 1. If it is not present, then we are not using 0. Simple, this technique. And here we are not counting, simple, but using simple first the technique. Here we are not counting the number of occurrences, counting occurrences. If suppose they are happy word, suppose let's this is the most frequent word we have, is we can see in a sentence. Suppose let's take this word is coming only, suppose you have 4 times in a text, 4 times it is coming in a text. So instead if this one is a the word, instead of using 4 here I am using 1. So just we are not taking the counting of the occurrences. So here I am not simple, not counting number of occurrences. Number of okay, simple, I'm not taking this one, I'm not counting taking, just I am, if it is on the text, I'm just making this thing is as simple as, because I was just using an example. So when we will discuss this thing, the text pre-processing, how to use this text in a classification technique as a regression technique, so then we'll see this thing in details. So just take this thing as simple as possible. Okay, now the thing is that we have a given text that is we call review, and after pre-processed this text, after using the pre-processing technique, text pre-processing, we have find this kind of backwards, that is w1 w2. After pre-processing we find that words, that is w1 w2 w3 up to wd, will get these words. Okay, now the main thing is that now for this text we are interested to find this text is for class 1 means it is positive or it is negative, for class 0 means negative. So what we have to find, we are interested to find now the probability of y is equals to 1 if it is positive, how much it is probability for this required text. First we are interested to calculate the positive. If it is the positive review, then we are interested to calculate the probability of plus y is equals to plus 1 and y is equals to minus 1 similarly. So between this probability we find the maximum one, so then we can easily call that this text is positive unless it is negative. So for this one we are interested to calculate it, probability of forward w1 w2 wd. Okay, so this is simple means our actually features, or as another language we call this is the words. So simple taking it is a features. Okay, so this thing we need, if you just remember the Naïve based technique, this thing is simple proportional to what, just we using here the Naïve based technique, simple we are using here Naïve based technique. Okay, if we just using the Naïve based technique, then this thing will be written as, can be written as y is equals to 1. This is simple, the class probability of the class 1, and probability of w1 with given class level 1, probability of w2 with given class level 2 to pertain d features, probability of wd with class level, sorry, I have make some mistakes to change it. This one will be 1. D for class level 1. I think clear? Just I am using the simple Bayes theorem here, nothing else. Okay. This will be the proportional. And we have seen this thing, we are just with this thing we are called a likelihood. But this thing we are called the likelihood. Is the actually likelihood. Okay. Okay. So in short, if you just write this thing in short, okay, just write it. In short, if we write it, y is equals to 1 for a given class, that is our actually required class. That is, it is actually xq if we call it. That is our query text. Is simple. Query text is equal to proportional equal to y is equals to 1 for this class into pi of I is equals to 1 to d. Okay, for the features, probability of wi, a given class level 1. Okay, this is for the one class level, and same thing we are can easily calculate the same thing for another class level. So let's take our another class level, y is equals to 0 for the given required text, for the given query text is equivalent to probability of y is equals to 0, I is equals to 1 to d, probability of wi our given class level is equals to 0. Okay, I think till now we will learn, and after finding this probability we can easily compare. The maximum one will be our required class level of the query text. Okay, this thing we have done in previous example. Now the main thing is how to calculate this likelihood value. We can easily calculate it. This probability of y is equals to 0, y is equals to 1 and y is equals to 0. So let's see how we'll calculate this value first. So first let's see. So if we just interest group, so first just I am giving another section. I think up to this we are clear. Now the main thing is how to calculate this probability. So first calculated this one, this probability, the probability of our class level. Okay, so probability of the class level 1, it will be simply, so this thing, suppose let's take our data set will be like this. So this is our data set. I think pictorial view is always better than analytical view, because we human easily understand from the picture. Okay, suppose let's take this is our features, that is our features, that is features vector, this is our y output vector, y is vector. So and here our actually text I, suppose let's say it is our text I, and here our suppose let's take it is 0 1, such kind of value it be what if positive. So this is our data sets, positive negative positive negative 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 positive, suppose like that, or y will be happen. Suppose it is text 1, it is text 2, dot dot dot. Suppose let's take it is text I, suppose this number of, suppose let's we have n number of text in the training data set, n number of data sets. Suppose let's take it is our this is our d train. This is our training data sets. So what will be the probability of the class will be 1, that is y is equals to positive review. As another language, the probability of the our output will be positive review. What will be this value? Probability of our positive review. So this is means that this value will be total number of points in the training data sets, total number of points in the training point. So simple train point, total number of training points, and it is taken in denominator. Simple by just doing the definitions of the probability, just simple definitions of the probability. So in numerator it will be the number of train points with number of training points with y is equals to 1. I think this definition is clear all of you, how we calculated this class 1 probability. So how much total point we have, and among this total point how much point we have in positive review. So this is the simple formula. Same trick we will apply in negative review also. That is probability of negative. This is y is equals to 0. So it will be total number of points plus number of training points with class level 0. Okay, it's the same thing we have done for negative reviews also. So now the main thing is that we can easily find these two probability, but main thing is that we have to find the likelihood probability. Okay, this is the main thing here. So how it calculated the likelihood probability. So to before calculate the likelihood calculatives, we have to use some trick to our data set that we can make easily calculated our likelihood. So let's see how we will manage this our data set. Suppose let's draw. I think it will be better if we just using. Suppose let's draw, it is our data set. Okay, and in these data sets we are using one thing. Suppose let's take it is our query point. Suppose it is our yi, and these things all our features vector, that is xi. And let's take, we have divided these two data point in this section in this manner. Suppose in the above portions we have taken here only positive review, only positive review, one, only positive review we have taken, and in the below of this data set we have taken the negative review only. Okay, and for this positive review our text, this is our sample, let's take this is our text ine. So we are simple just divide our data set in positive reviews. This is simple the positive reviews, and this is simple our negative reviews. I think it will be better if we use the same color. Okay, it's a simple, I'm using divided. This string is this trick, it's simple, make our calculation so easy. So let's see how we will calculate this thing. Now we are interested to calculate it probability of suppose what this is means this thing we are interested to calculate it, this thing wi, or let's take our class level 1. In denominator first we just for we are interested to first we are interested, this means what, this means we are interested in class 1 only. So first we have to find the Number of training data points with class levels is only 1. Number of train data points with our class is equals to 1, means we are just simple interested in this number of points. We are simple interested this number of points. Okay, nothing else. Now in numerator we have to find what? We have to find the number of points which contains the wi. So we are interested to find this point which only contains wi, and in these classes and in this y is equals to plus, means in these sections, in the first portion, in the first part of this data, means this positive previous data, we have to find these words which contains only wi. Okay, so just write down. So number of train, okay, number of train data points with content, which content, number of train data points is which contain this or wi, and our y is equals to 1. So I think this thing is clear, all of you. How will the how we calculated this likelihood probability for class 1, that is for positive review? The same thing we can easily do for the negative classes also. So it's the same thing. Here we are using 1 simple, here instead of using here we are using 0. Similarly here instead of 1 we are using the 0th class. Just we are considering this second, the next part of the class, the second part of our data sets, that is negative review data. Okay, we are just calculated this same thing in these data sets. Okay, now I think this is simple, our train data set. I think this idea is clear, all of you, how to calculate this thing. So in the text classification problem, in the problem of text classification, if you just consider only text classification, most of the time this naive Bayes technique is called the baseline model. Okay, it is so good for only for text classifications. Most of the scientists, most of the engineers are taken this naive Bayes algorithm is as a baseline model for text classifications. So why? Because let's see what is baseline models and why it is called the baseline model. So let's see. So naive Bayes is as good most of the time, typically most of the time it is a baseline model for text classification. Okay, so now let's see what is baseline. Let's see what we call baseline or benchmark, or another language it is called the benchmark. Why? So this means suppose we have a text classifications problem, and in this problem we are using various kind of algorithms. Suppose let's just see one by one. Suppose let's take first, we are applying in this problem the naive Bayes problem. Okay, after applying we have find this accuracy. After applying this model we have find this accuracy of this model. So let's take, we are getting the accuracy of this model is 98%. Okay, and suppose let's take we are applying another model. Suppose let's take we are using the logistic regressions, and let's take here accuracy. So let's take 90, suppose let's take 92%, and let's take we are applying the gradient boost decision tree. Let's take it's in this model gradient boost decision tree, its accuracy, suppose let's take 94%. Okay, and let's take we have been using the deep learning model. So let's take in accuracy of the deep learning model is, suppose let's take 98 point, suppose let's take 98.5%. So what will be the highest value here? 98.5%. So it will be the benchmark according to the accuracy value. Deep learning model will be the benchmark about this problem. If we just apply this thing in the text classification problem, it will be the benchmark. But the main thing is, if you just see, Naïve based is so simple. Naïve based is so simple and sophisticated algorithm. But in deep learning, it is so complex. Okay, and here we have required so huge amount of resources. We have to invest so much money in deep learning to build a deep learning model. But in Naïve based, it is so simple. Here we have not invest anything. Just simple using counting technique, we can find its accuracy 98%. So simple, because of only 0.5% accuracy, we have to invest so huge resources. Because of improvement only 5%. Because of this reason, because only for this reason, this Naïve based technique are sometimes called the benchmark baseline model for text classification problem. Nothing else. Okay, this only because here we require huge resources. But our Naïve base is so simple and so simple. And one thing is that here we only get just 0.5% improvement. Okay, nothing else. Only for 0.5% we cannot invest so much huge resources. Okay, so because of this reason, because only for this reason, this Naïve based technique sometimes called the benchmark mode, benchmark for text classifications. Okay, I think how much important this Naïve based for its simplicity and for its sophistications, and why we take this as a benchmark model, I think, and how it is required for a text classification problem, and how simple we can build a text classifier, and why for spam filtering, for reviews, for classifying the review data sets, how it is important. I think this from this lecture it will be clear all of you. Okay, so bye, we'll see in next lecture.